Hello, and welcome to Advanced Mathematics 1, Unit 7, Part 4, Percent and Ratio Problems. By the end of today's lesson, you'll be able to do the following. You'll be able to solve ratio problems, and you'll be able to solve percent problems, which is pretty obvious from the title. The main concepts for today are as follows. Your basic idea is to set up a ratio and then cross multiply to solve. You just got to make sure you're cross multiplying the correct thing when you're doing ratios that involve more than two things. I usually use what's called a ratio box. It's just a way of organizing the data. It can be very helpful for solving problems, especially when the ratio problem has totals or there's an increase or decrease in the percent. For increases and decreases in percent, the original percent is always 100%. So let's say it says that the percent increased by 25%, then the original percent is 100, the increase is 25, and the new percentage is 125%. All right, in our first example, it says the ratio of chickens to ducks was 9 to 4. There were 108 chickens. How many ducks were there? So there's just two things involved. This is a normal ratio box between chickens and ducks. We're going to start by writing the ratio of chickens to ducks in the first set of boxes. So the ratio is 9 to 4. And then it asks when there are 108 chickens, how many ducks were there? Now you just cross multiply to solve. So we have 9 times D equals 4 times 108. So I don't know what 4 times 108 is off the top of my head, so I'm going to look it up. That's 432. So sorry about that. My pen is rolling all over the place. Sorry about that. So 9D equals 432. Divide both sides by 9. So do that. That's 48. So there are 48 ducks. I guess I should have written D equals 48 over here. Not that it really matters, but there we go. That finishes the problem. So 48 ducks is what we have. So in problem 2, it says the ratio of fish to crabs in the cave was 13 to 4. If there were 119 fish and crabs in the cave, how many were fish? So this involves a total of the fish and the crabs. So this requires a 6-way ratio box. In other words, 3 on both sides. So I'm going to have my fish, my crabs, and then my total. So fish plus crabs is total is basically how that works. And now we're going to fill in our box with the information from the problem. It says ratio of fish to crabs was 13 to 4. So I'm going to put 13 and 4. So for the total, I would add those up. So 4 plus 13 is 17. And then it says if there were 119 total, how many were fish? So we're looking for fish. So we're not going to use that middle box. We're just going to cross multiply here. So we have 17F equals 17 times 119, or 119. So 17 times 119 is 2023. I'll recopy the 17F. Divide both sides by 17. And you get 119. So there were 119 fish. And there we go. All right, so it says 3,600 of the troops were still alive after the battle. If 40% died in the fight, how many troops were there to begin with? So this involves people that are alive and people that were died and the total amount of troops that there were to begin with. So it's another 6-way ratio box. It involves percents. So on one side we'll have ratios and the other side we'll have percents. So we have the ones that are alive, alive, the ones that died, and the total amount of troops there were to begin with. We're going to start with the number actually of each, and the other column will be the percent. So the number alive after the battle is 3,600. The number that died, we don't know. We don't know the number that there were to begin with. That would be the total. So we're going to put that in there. The percents, we know 40% died in the fight. Total percent is always 100%. And then we would subtract to get A, because A plus D is total. So this would be 60%. Now you can choose to use that as a 0.6 or 60 over 100. It does not matter how you do this. But again, I don't need the middle box at the end. I just need these 4 boxes. So I have total times 60%, so 0.6 T equals 3,600 times 100%, which is 3,600 times 1, basically. So we're going to divide by 0.6. So 3,600 divided by 0.6 is 6,000. So there were originally 6,000 troops. And that's a 6,000, not a D. So there you go. All right, let's move on. Okay, in example 4, it says the Richards family bought some new camping gear at REI that totaled $318.50. If they receive a 30% discount, what is their total bill? So we're dealing with a decrease in percent. So when we set up those boxes, either increase or decrease, we're going to have an original amount. We're going to have either the increase or decrease in percent. This time it's a decrease. So it'll be original minus decrease is going to be the new amount. Don't need that big of a box, but it's all good. We're going to have numbers in one column and percents in the other. So let's read the problem again. They bought the gear for $318.50, but then they received the gear cost $318.50, but they received a 30% discount. I'm going to go ahead and put that 30% discount in. Original percent for these problems is always 100. That means the new percent is 70. 100 minus 30 is 70. So that $318.50 would be the price that this originally cost because they received a discount after that. And their new cost is their total bill. I'm just going to call that X. It doesn't really matter what you call it. So I have cross multiplying just these 4. We have 100 X equals 318.50 times 70. So let's multiply that out. So 318, can't type today, 318.5 times 70 is 22,295. So 100x equals 22,295. Then we're going to divide both sides by 100. When you do that, the decimal point just moves back 2 spots, so it's an easy division. So we get x equals $222.95. So what they ended up paying is $225, $22.75. And that's all for today, and I will see you next time. Goodbye.